Hi everyone, Mrs. Jones here. Welcome to equation solving, which I must admit might be my favorite part of pre-algebra. It's really a foundational piece of the rest of the school year and, to be honest, the rest of your math career. So let's begin. The most important rule that you are going to learn today is the golden rule of algebra. And the reason that I've put a balance here on the page is that the golden rule of algebra is that whatever you do to one side of an equation, you must do to the other side of the equation. In other words, if we have a balance, we have to keep that balance balanced. Meaning, if I do one thing to one side, I have to do the same thing to the other side to keep that balance. A couple of pieces of important vocab that I want you to learn is something called inverse operations. And inverse operations in math are things that undo each other. So addition and subtraction undo each other, and multiplication and division undo each other. Let me show you what I mean by that. Here on this page, you'll see that we have 4 one-step equations. When I say one-steppers or one step, that means that I need to do one operation in order to solve the equation. And our goal here when solving these equations is to isolate, meaning get by itself, isolate x or the variable if it's not x. So let's begin here by solving each of these. I want you to first think here, what is attached to x? The thing that is attached to x is this 2, and it's attached to the x by addition. Now remember on the last page, I said that subtraction undoes addition. So in order to isolate x, or in other words, to get x by itself, I need to get rid of this 2, and I'm going to do so by subtracting. I'm left on the left-hand side then with just x. Remember, it's a balance. Whatever I do to one side, I have to do to the other. So I'm now going to subtract by 2 on the right-hand side, and my solution is -9. Moving on. Here we have 9 that's attached to the x by subtraction. Well, we know that addition will undo subtraction, and so I'm going to add 9. I want to get rid of this 9 so that I'm able to isolate my x. In doing so, this will cancel out, and I'll be left with just x. Thinking about, remember, -9 plus 9 is 0, so that works. I need to keep it balanced, so I'm going to add 9 to the other side, which is going to result in an answer of +24. Okay, here we have fraction, but remember this division line right here, this fraction means division. So multiplication undoes division, excuse me. So I'm going to multiply by 3 on both sides. This is going to think about it as being 3/1. I can cross cancel here, which will reduce just to x, right? So I've canceled out my 3's here. I need to keep it balanced, so I'm going to multiply by 3 on the other side, and my solution will be -6. If we think about this next one, consider the fact that this is invisible multiplication, and I know that division will undo multiplication. So I'm going to divide by 4 on both sides. 4x divided by 4 is going to get me to just x. I have to keep it balanced, so I'm doing the same thing to the other side, which will result in an answer of -3. I'm sure that a lot of these you could have probably done quite easily in your head, which is great, but I took the time on this slide to really show you the work and the way that you can prove your answer, because they're about to get pretty complicated. All right, I'd like you to pause the video here and try these 4 on your own. Again, I know you can probably do it in your head, but I really want you to focus on showing your work, showing that balance of doing the same thing to both sides. All right, you're back. Notice how carefully I've shown my work here. Oops. There we go. And on this orange problem, I just want to remind you that on the right-hand side here, I've gotten to 32 divided by -6, which I then need to reduce. So always make sure that you're simplifying your fractions. All right, let's move on. We now need to think about two-step equations. Well, the reason that this 2 steps is that it's going to require 2 things of us. And what's really important is that we first notice what is attached to x and how is it attached to x. So I can see here that I have a 5 and I have a 2. I also, therefore, have 2 different operations going on. And the operations that I have are subtraction and an invisible multiplication. Well, you remember from earlier this school year, we reviewed PEMDAS, right? Well, when you think about PEMDAS, you're actually going to use it here, but we're going to go backwards. And the reason that I say that is that we have multiplication and we have subtraction, but we're going to go backwards. So the thing that we're first going to deal with is this subtraction. I know from earlier that addition will undo my subtraction. So I'm going to add 5 to both sides of my equation. This will cancel out on the left, so I'll be left with just 2x. And then negative 11 plus 5 will be negative 6. Now I just have one operation to deal with, and that's this multiplication. I know that division undoes multiplication, so I'm going to divide by 2 on both sides, again, keeping that balance and thinking about my golden rule. So my solution here is x equals negative 3. Now, a quick side note, if you wanted to check your answer, meaning let me just double check that negative 3 really works, I would take my original equation of 2x minus 3 equals negative 11. Whoops, negative 5, sorry there. Okay, minus 5 equals negative 11. I'm going to take this value of negative 3 and I'm going to go plug it in to x because that's what I solved for. So now I'm saying 2 times negative 3 minus 5 equals negative 11. Well, I know 2 times negative 3 is negative 6. Negative 6 minus 5 is in fact negative 11. So I did it correct. Feeling good. All right, let's move on. You'll notice here that these two equations look a little different than the last one. And the reason for that is that my x term, my variable term, is not first. But remember that we have something called the commutative property, and we can rearrange this. I can think about this equation as being 3 plus negative 2x equals negative 5. This then allows me to rearrange this and put that variable term first, which personally makes me feel a lot better about the equation. So I'm going to rewrite this as 2x plus 3 equals negative 5. I then see that I have my two operations going on. I have addition and I have multiplication. I know I'm going to go according to backwards PEMDAS, which means I first need to subtract 3 from both sides. When that happens, I'm left with negative 2x equals negative 8. And now I'm going to divide by negative 2 on both sides. So my answer is going to be x equals positive 4. I want you to try the equation on the right, so pause the video and give it a shot, thinking about how could you rearrange it. All right, hopefully you've rearranged it to be negative 3x plus 4 equals 10, and then hopefully you solved it to get x equals negative 2. I want you to pause the video here and try these 4 two-step equations on your own. All right, hopefully A felt easy. That was actually a one-stepper. B, perhaps you thought about rearranging it. Whoops, rearranging it, there we go, to be negative 7x plus 4 equals negative 10. C, remember we're dealing with addition to undo my subtraction and then multiplication to undo my division. And D, perhaps you also thought about rearranging that one. Whoops, your answer should be x equals negative 4. All right, moving on. Whoops. Last two. What if we now have fractions and decimals? I want you to pause the video and try these two on your own, and then we'll come back and go over them together. All right, you're back. So my suggestion, and perhaps you've thought about this, is that on this top one, I want to think about common denominators, because I know that when I'm adding, subtracting fractions, I need to think about common denominators. So I know that the common denominator of 3 and 4 is going to be 12. So I'm going to be left with x plus, well, 2/3 is the same as 8/12, and 3/4 is the same as 9/12. So now I'm back to my basic one-stepper of I'm just now subtracting a fraction instead of a whole number. And my solution is going to be x equals 1/12 because I know 9/12 minus 8/12 is 1/12. Hopefully you feel like the same thing here with my decimals. I'm just going to subtract 4.3 from both sides. I know, though, that I'm subtracting two negative numbers, so my answer here is actually going to get more negative, which means I'm going to actually add them. So this should become negative 16.7. So hopefully this helps. Again, this is a really huge foundation for the rest of pre-algebra and algebra. So if you need to go back and watch this video again, please do so. If you have more questions, please feel free to reach out to your teacher. And good luck with your work. Don't forget that golden rule.